Hello, Stat 200, and welcome to Lesson 10. This week, you're going to be learning more about correlation and simple linear regression. You were first introduced to these topics in Lesson 3. Before you begin this week's lesson, you should go back to review Lesson 3 in the online notes. You should also review Sections 2.5 and 2.6 in the Lock 5 textbook before reading the new content in Section 9.1. The new content that you're going to see this week will deal with statistical inference with correlation and regression using common distributions. Both correlation and regression use the t-distribution to test for statistical significance. Again, before you begin working on the new content, I strongly encourage you to go back to Section 3.4 of the online notes to review scatterplots, correlation, and simple linear regression. You'll see these topics again this week, and we'll be building on what you've learned in previous lessons. These are the key topics that you'll learn about this week. In terms of statistical inference with the t-distribution, we will construct confidence intervals and conduct hypothesis tests for correlation and simple linear regression models, specifically the slope. In this lesson, you'll also be introduced to the coefficient of determination, also known as R-squared, which is a measure of effect size for correlation and regression. If assumptions are met, for example, linearity, we can approximate the sampling distribution for Pearson's R and the slope with the t-distribution. We'll walk through all of the assumptions in the next few slides. We will use the 5-step hypothesis testing procedure again this week. Minitab Express will compute your test statistic and p-value for you. While the formulas are given in the online notes and in the textbook, you'll never be asked to compute the test statistic by hand from raw data. The calculations aren't necessarily difficult, they're just tedious and very time-consuming. You'll just need to check assumptions. On the next few slides, we're going to walk through the assumptions for both correlation and regression and how to check them. For correlation, the only assumption is that the relationship is linear. We check this by looking at a scatter plot. Remember, Pearson's R is only meant to be used with linear relationships. If the relationship is non-linear, then Pearson's R should not be used. For simple linear regression, there are 4 assumptions. I like to remember these using the acronym LINE. Linear relationship, independence of errors, normality of errors, and equal error variances. We'll walk through one example of checking each of these assumptions. In Minitab Express, when you're obtaining your simple linear regression model, you should click on the Graphs tab and then select Residual Plots. This will give you all of the graphs that you'll need to check all 4 assumptions. For linearity, we're going to look at the scatter plot again. The scatter plot that you get with your regression output will have the regression line drawn on it. That line will always be straight because it is a simple linear regression model. You should ignore the line and just look at the dots to confirm that the line of best fit really is a straight line. The second assumption is independence of errors. This means that the errors, which are also known as the residuals, are not correlated with the predicted values. From earlier this semester, you might remember that a residual is the difference between the observed and predicted y values. In other words, y minus y hat. This plot is known as the plot of residuals versus fits. When we look at this plot, we should see no relationship. The third assumption is normality of errors. This means that the residuals should be normally distributed. Minitab Express will give you 2 different plots of the residuals. First, we have a normal probability plot. If the residuals are normally distributed, they will fall on this line. The second plot that we have is a histogram of the residuals. This histogram should be approximately normally distributed. The fourth assumption is equal error variance. We're going to look at the plot of residuals versus fits again to check this assumption. Now, we're looking to see if the variance of the residuals is consistent across all fitted values. In other words, the spread of the residuals should be the same across all fitted values. Before interpreting your simple linear regression model, you should check all 4 assumptions first. This brings us to the last topic that I'm going to cover, the coefficient of determination, also known as R-squared. This is a measure of practical significance. It is a measure of effect size that can be used with correlation and regression. It is literally equal to r squared. When I first started teaching, I used to get a lot of questions about how to compute r squared. You take the Pearson's R correlation coefficient and you square it. Because it's a squared value, it will always be positive, and because Pearson's R is always between -1 and +1, r squared will always be between 0 and +1. It measures the proportion of variation in y explained by variation in x, and vice versa. So it's the proportion of shared variance. This concludes the Lesson 10 overview. If you have any questions this week, please post them to the Lesson 10 discussion board on Canvas.